Hello.
How's it going?
All right. How are you, Adam?
Good.
Um, can I share my screen just to at
Yeah.
least make sure it's not
Yeah,
uh,
if you want to share audio, just make sure to click that button.
like if I was playing a video?
Yeah.
Okay, cool.
That's a cool picture. Oh, is this in Iceland?
Yeah.
Okay. And did you want to record this session to make it available for people that can't make it?
Um, is it an
It's totally
option to
it's
record
totally
and
up to
then
you.
yeah, I guess I'd like to have the recording available and if it's okay, decide whether I want to share it after being able to view it
Okay.
privately.
Yeah. I'll start that later.
Cool. Is there an estimated attendance?
Sure, let me check the Loom. Uh, it a bare minimum four from what I'm seeing on the Climate Vine, but I don't know where the Luma page is, so I'm not sure who all outside of Climate Vine's coming.
Cool. Well, I'm totally cool with low pressure.
Hey, Jonathan.
Hey, Candace.
How's it going?
Doing well. How are you?
Very good. Sorry for my delay. We usually start these calls, I think like 2, 3 minutes late. And so we'll play the visitor. Thank you for sending me that. And then uh, I guess I'll briefly, Adam, do you want to introduce or do you want me to introduce
You can do introduction. Yeah.
of you and Jonathan or just of Jonathan?
Just Jonathan. I'm
Okay.
just here taking questions on the back end.
Amazing. Um, and we have so far 17 yeses, which might mean 20 people show up, and it might mean 5 people show up. It's very hard for me to predict some things. I've got it recorded. Do you want it recorded or do you not want it?
Yeah, I do want it recorded. I would request that I be able to view the recording before I
Yeah,
say that I'm comfortable with it being disseminated.
totally. And if afterward you're like, can you guys cut out this part? Like if you know anything after the call that you want us to cut out, feel free to just message me to do that.
Cool. Yeah. Yeah, there's a couple of things that are like references to client work that are,
Yeah.
it's all kosher to do in a meeting like this, but then sometimes, you may not want it to be out
Yeah.
there publicly.
And it
So,
will only actually ever go to climate by members. So that's another thing about a recording.
cool.
But we have, I think, we have 3 people in the audience, which is fun. Including is Edmund Butler, someone on your side?
Yes.
Okay. Should I let him in?
Yes, you should.
Okay. Cool. And I guess one of my questions is just, well, I guess to start, sounds like you'll do a presentation and then take questions throughout or at the end. What sort of format do you want to do?
Um, I was planning on running through the slides and nominally aiming for a half hour, and then I'm totally open to Q&A. Flexible if people want to interject and ask questions while I'm presenting. It's yeah, pretty flexible and formal. I don't. It's not like a you know
But
rehearsed presentation or anything like that.
yeah, Adams, why don't you, if there's like a question that you think should be answered at the time, you can just go off mute and say something.
Yeah.
Um, and then is there anything that Jonathan that we can do to just like make this a good experience for you? Or you can ask something of the audience, you can ask for, you know, whatever you want. But is there anything that I can do?
Not that I can think of right now, but I appreciate you asking. I'll let you know if I think of anything.
Nice to meet you, Edmund. All right. I'm gonna do computer audio and just start this song. Tell me if you can hear it. Yes or no? No.
Yeah.
Great. I think I might have to seal it for you then. Yep.
Very loud. Way too loud.
Better?
Still loud.
Uh, I think you might just have to lower it on your side.
You got me.
Okay. All right.
Sorry.
Just passing through though, I can't stay long. I'm just a visitor and I don't hang around. I got places to go because I'm covering ground. I'm just a visitor and I don't hang around. I got so many places to put my foot down. They call me Bigfoot because they found a print on the ground. But that's not the only way I get around. They call me Sasquatch, but it's all the same because people cannot pronounce my real name. I'm over here, I'm over there. I got a place underground, I got a place in the air. I got a place where I go when I need some space. And when I want to relax, I like to play the bass. I like
That's an awesome song. The Visitor by Bicycle with DJ Jonathan. So Jonathan, I'm going to give you the floor and then we'll see as people sort of trickle in. They can sort of catch on and we'll give them some info in the chat as well. But short intro is your principal and owner of Scientific Web Services, which is a geothermal energy software company. And you're a friend of Adam's. And Adam, thank you for bringing in Jonathan. I think those are the main intros. But Jonathan, you should maybe expand on that. I'm sure you will in some of the presentation. Otherwise, I'm just going to give you the floor. Feel free to share your presentation. The format, by the way, for everyone is about 30 minutes presentation. Feel free to drop questions throughout. If you have a question that's pertinent, you can go off mute and share it. Adam will be looking at chat questions as well as I will. I think that's it. Jonathan, why don't you take it away and bring in anything that you wanted to do into the go.
Yeah, thanks so much, Candace, and thanks to Adam for inviting me to do this presentation. Adam reached out to me because I posted a analysis that me and one of my collaborators at NREL did, showing a 2.77 cents LCOE for a extrapolation of a currently built next generation geothermal project. And yeah, I decided to take this opportunity to talk to a broader audience about the potential of next generation geothermal energy and what it might look like to get to that that sort of LCOE and yeah, so excited to share that with everyone. We'll pull up the presentation here. So hopefully everyone can see my screen. Yes, okay. Yeah, so like I said, this is a overview of next generation geothermal energy. This is a picture from Iceland of one of their geothermal plants. Iceland has many geothermal plants because they have a lot of magma close to the surface. So just a quick overview of what we'll touch on in this presentation. Just do a quick geothermal energy 101 about me and my involvement in geothermal energy, some details on geothermal economics and techno-economic analysis and case studies that we've done, and then extrapolating to what does the path to 3 cent or less LCOEs look like. So quick stuff about me. My background is in software engineering and computer science and AI. And previously I was at Microsoft and AWS for a combined total of 10 years. And my personal experiences with climate change, including wildfires, ultimately led me to see what impact I could make in the climate change space, and kind of got the picture around decarbonize and electrify. And geothermal has wound up being an area that's into the electrify part of the picture, and happens to have the needs that match the skills and interests that I have. So yeah, that's initially I was involved with open source contributions to some geothermal packages, and then that wound up transitioning into getting clients and funding, and just become a full-time job. So it's been a cool little trip so far. And then yeah, specifically I work primarily on an open source techno-economic analysis tool called GeoFires. And that's in collaboration with NREL. And then just a couple of quick disclaimers. Everything I'm saying is my own views and analysis. I'm not representing anybody besides me and my own company. I've got sources, but please feel very free to ask for further clarification. And in general, geothermal is very complex and interdisciplinary. And I am not a geologist, a geophysicist, a geochemist, a reservoir engineer, a driller, a power plant designer, or an economist. So my involvement is taking the codified knowledge of those domain experts and providing software that builds the open consensus around what does the picture look like. So I will defer to experts in those areas for if there's anything competing with what I express. So and yeah. So number one, what is geothermal energy? In the context of this presentation, we are talking about utility scale electricity generation, geothermal, next generation geothermal. So the idea is that you drill a hole into the ground down to an area in the subsurface that has heat in it. Then you pump cold water down that hole. It gets heated up by the heat in the subsurface, and then it returns as boiling hot water, or superheated water, or even supercritical fluid, to drive a power plant, and you produce electricity that way. So that's a fun animation there. And this is just a single injection well and production well. Actual geothermal plants will have many injection and production wells, perhaps in the order of 40 to 80 or so, depending on your capacity. We're talking about 500 megawatts or so. So yeah, that's from a physical and system standpoint, this is sort of the working model here. There are various technologies and that are used to achieve this sort of system. There's conventional hydrothermal, there's enhanced geothermal systems, there's advanced and or closed loop, but they all operate on essentially the same idea of you have a hole that you are putting cold water down, and then you're producing hot water that you use to drive a steam turbine or a binary plant. And yeah, it's all about utilizing that temperature gradient to extract enthalpy. So in the status quo, most geothermal plants are in volcanic and tectonic areas, and this is a map of approximate capacity around the world. And this is kind of an old installed capacity number, but geothermal is a very marginal source of electricity today. I believe in the US it's about, or globally it's about 0.4%, if I recall correctly. US geothermal production is around, I believe it's now around 4,000 megawatts, 4 gigawatts. And it's small. We have a little bit more here. And these are the locations of those. So California has a plant called the Geysers, which is responsible for perhaps all of this 2.6 gigawatts, or at least the vast majority. Nevada also has some plants. Hawaii has a plant on the Big Island called the Puna geothermal plant. And then, yeah, there are a couple of other smaller plants in a couple of the other Western states. And as I alluded to, the Geysers, it's the world's largest geothermal field, and it produces about 20% of California's renewable energy. So that's pretty cool. Recently, there's been steady and increasing growth in worldwide geothermal electricity production. The numbers for 2024 just came out. It's about 16,873 megawatts. And you can see the US is leading that. We've got Indonesia is a big developer right now, Philippines, Turkey, New Zealand. So yeah, it's growing, and there's a lot of interest in it, in large part due to the advancements in next generation geothermal that we'll be focusing on. So why geothermal energy? So it is clean, firm, dispatchable baseload energy. It's compatible with the existing grid. It is, from a thermodynamic standpoint, an effectively inexhaustible resource. It has very small footprint, 1 to 8 acres per megawatt. And I believe that is the smallest of any renewable energy technology. And there's high transferability of the existing resource, technology, logistics, also market and finance instruments in theory translate over. from the oil industry to geothermal in some ways. And just as a thought exercise, right now we drill about 15,000 oil wells in the US every year. And if we were to hypothetically change that over to geothermal wells, we could decarbonize a very large percent of our electricity in a very short time. I obviously that's probably not going to happen for many reasons, but as a thought exercise of the potential, it's there, and it's a matter of economics and will. So yeah, the on paper geothermal looks amazing. It looks like a panacea. What I'm going to discuss today is some of the, what is the pathway to actually getting there? What are the caveats around that? And how much of this picture can we actually realize? So some more advantages. It's utility scale projects are already being built. There may be highly favorable economics, 3-cent LCOEs, or even just favorable enough economics would be great too. They can be built on the sites of retired fossil fuel plants, which is great, retired coal plants, relatively minimal environmental risk and impact, baseload energy, as I alluded to earlier. So yeah, lots of good stuff going for it. And there are also, I won't be talking about this in this presentation, but there are also other applications beyond electricity. There's direct use heat, there's district heating, there's residential heating, there's direct air capture. So there's lots of things that you can do with an energy gradient that you can harness anywhere, and that's cool. Or hot, depending on your needs. And these are some references for dispatchability and grid electrification. If you want to follow up after this presentation, there's some more reading on that. And another area is they can also be used to essentially co-produce minerals, and that's mainly relevant in the Salton Sea. There's some wild numbers flying around about using geothermal to extract something like $500 billion worth of lithium from the Salton Sea. I don't keep up to date on the hype on that, but that's another interesting area of geothermal. But what we're going to focus on is electricity generation. So there was a recent paper by Ricks and Jenkins out of Princeton University estimating that we could achieve a national capacity of 250 to 750 gigawatts by 2050. So that would be around 20% of total US generation. That number has been referenced by at least one member of the White House administration in the previous administration. So there's believers in that, and most of the potential is it's more in the western states, but it's still there's estimates out there saying that this could really be a significant part of our electricity generation. So we're hoping that continues to manifest in reality. So why haven't we already done this? Why haven't we just been building geothermal since it was possible? So the main reason for that is first that existing geothermal is mostly conventional hydrothermal, which relies on very rare geological formations that have natural steam present in the subsurface. And so like the geysers is one of those, and we've built the geysers, but there just aren't that many of formations that are suitable for that. And then the technology to so with next generation, the essentially what the gist of it is replicating this, but providing our own water. And that's called enhanced geothermal systems or engineered geothermal systems. And it is more costly and complex to do that because instead of utilizing an existing aquifer, you have to drill down into rock and then fracture it and then inject water, and you have to ensure that the water is able to flow, and it's more complicated, and it requires advanced drilling technology, and it's expensive, but the various technologies and logistics that are necessary for that have sort of coalesced in the last 10 years to where it looks like it's going to be economical to build these next generation systems. And yeah, as I mentioned, so enhanced geothermal systems, making your own artificial version of the hydrothermal reservoir requires stimulation or fracturing. And yes, this is very similar to the fracturing used in oil production. It's done with primarily with water as opposed to hydraulic fracking fluid, but it's a similar principle of you are applying very high pressure inside of a hole that then creates fractures in the rock that liquid flows through. When it's oil and gas, you're using hydraulic fluid to displace oil and gas that is permeated within the rock. With geothermal, what you're doing is you are creating flow paths for water to go to find its way from your injection well to your production well. So that's the main difference there. And there have been rapid advances in the ability to do that. The technology is different and the techniques are different from the oil and gas industry, but they've been adapted, and there's really been some very rapid advancements made in that area. And then yeah, so just talking about geothermal energy techno-economics. Imagine some of you might be familiar with techno-economics, but just a quick refresher. It's just the taking the economic performance with a coarse technical specification and producing sort of a screening or analysis of that holistic picture. So the DOE has set a Earthshot target of $45 per megawatt hour, which is 4.5 cents per kilowatt hour by 2035. And in general, the industry consensus seems to be that is going to be achieved, and probably early. So yeah, that's really promising and great news if those trajectories continue. There's also the ARPA-E Super Hot program, which is aiming for 2 to 3.5 cent kilowatt hour LCOEs. And that is, as the name implies, getting down to reservoir temperatures that are super hot or in the supercritical state. And there are essentially a variety of reasons why super hot reservoirs may be the ultimate way that we get to these truly extremely low LCOEs. But essentially the higher enthalpy of water at supercritical state or at near supercritical temperatures is favorable to the economics in a variety of ways. So there are a couple of techno-economic simulation tools that are used for geothermal analysis. I don't know this audience super well, but I imagine people in the renewable energy space are pretty familiar with SAM. So SAM does have a geothermal module called GET'em. You can also do geothermal analysis with a custom generation profile in SAM, if anyone's familiar with that. So this is an example of doing a custom generation analysis with the case study that we will be looking at, but just showing you can set it up so that you are producing your baseload energy. You're getting the same net generation all the time, and then yeah, getting your NPV, your IRR, all those nice things that we like, and cash flow tables as well. And then there's also GeoFires, which is the primary tool that I work on. GeoFires is has the bicycle economic model, which is a little less sophisticated than SAM, but GeoFires has a more sophisticated representation of the geothermal system. And so GeoFires, a lot of my work focuses around clients that are interested in using GeoFires for research or analysis or extending it for whatever purposes they might have. And yeah, it's about one of the core purposes of it is to drive open consensus between industry and public sector and give us a clearer picture about what next generation geothermal is going to look like from a techno-economic standpoint. And I self plug here, but there's a free interface for those that want to try it out themselves. It is technical, but you can play around with it if you're interested. And then, so just a quick comparison here around what LCOEs look like with different models here, just to give you just as a perspective on, there's not necessarily one LCOE for a given system, but this is just showing there's different levels of coarseness. You can do pro forma cash flow analysis or bicycle model. So there is some variation in some of the numbers I'm about to discuss depending on the model you use. Just as hopefully that's helpful. So the main cost drivers for a geothermal system, number one is drilling costs. So with geothermal, you are looking to produce water that is superheated and ideally at least 200 degrees C. And it's pretty much better the hotter you get. Possibly up to like 450 C, possibly beyond that. But yeah, it's all about for a given site, you need to drill down into the earth until the temperature of the rock is the temperature that you want to produce water at. And then actually you have to be a little bit deeper because you lose a little bit of heat as the water comes up the well. And drilling is very expensive. It is rapidly, there are rapid advances in cost reductions, but this is one drilling model for if you wanted to drill a well that achieves a given temperature today. In some of the common gradients, you could be looking at over $100 million a well. Some of them, so for example, at the 28.3 Celsius per kilometer gradient, you would actually have to be drilling a hole that is deeper than the Kola super deep borehole, which is the deepest hole we've ever drilled. So yeah, there's a lot of the future of geothermal really just depends on how cheaply we can drill deep holes in places where gradients are not as naturally favorable, and then so drilling costs, and that's converts to your production temperature. There's also your flow rate, so the amount of hot water that you're producing from your wells is keeping that up to the spec is critical because if you lose your water, you lose your enthalpy and then your power. There's also pumping power or parasitic load, which is the electricity that you generate that you then have to use to keep the system flowing. There's also the surface plant, the power plant, and geothermal power plants can be complex and expensive. And then just in general, these plants have, if you extrapolate out to like 400 or 500 megawatts electricity, you start getting into like the billions of dollars range for your capex, and the cost of capital starts to become very significant at that point. So those are the cost drivers. This another way you can look at it is what are the risks. So I won't read every point here, but these are um, some of the main risks and reasons that things that you would need to assess for a geothermal project. How are we doing on time? We're at 30 minutes. Okay. Yeah. Other risks and considerations. I contrast EGS with fission nuclear a lot, and both are great because they are technologies that can scale. Maybe not necessarily infinitely, but they can on paper scale to meet our generation needs, and they're clean, firm, they're compatible with the existing grid. Nuclear has the advantage of having a decades long track record. EGS does not. And then geothermal is an electricity generation standpoint. It's not like solar, like rooftop solar, where you can just slap it together. We're talking hundreds of millions or billions of capex. It's not going to be something that the average person is just going to build a geothermal well in their backyard for electricity. And then there are some caveats to flexibility and dispatchability that I'm not qualified to speak on the details of, but there are some caveats to that. Okay, so now getting towards talking about specific LCOEs. So the model that we've used in GeoFires and the model of the case study that Adam asked me about is called the bicycle model. So that was developed at Los Alamos, and it's just a pretty simple calculation of LCOE. The formula is here, and basically you have your costs over the amount of electricity that you produce. I'm sure many of you are familiar with that concept. And more sophisticated financial models, we use a pro forma cash flow analysis. There's a couple of shortcomings to this LCOE method. The biggest one might be that it doesn't discount the capital expenditure correctly if you have a significant investment tax credit, which if we're talking about building in the US, you might be talking about a 30 to 50% ITC, and this model tends to overestimate the value because of that. And then LCOE in general has limitations, and I won't rehash them all here. I'm sure many of you are familiar with them, but essentially, that it may not necessarily be it may not be valuing baseload power correctly, and it has pros and cons to it. So yeah, sometimes we see an LCOE, but there's much more to the picture, and I would encourage people to bear that in mind, at least when it comes to geothermal. So yeah, when I work with clients, we do look at LCOE. We also look at NPV. We look at internal rate of return. We look at the profitability index as well, and the ROI or MOIC, multiple on invested capital. And especially when you're talking about billions of dollars in capex, all of these metrics are important. There's also cost of debt and financing versus equity, and there's a whole world of how these financial instruments work, and an LCOE is just one of many metrics that are used to assess these types of projects. All right, so now talking about Fervo. So the main case study we'll be talking about is Fervo Cape Station, but first Fervo did Project Red. This was essentially a test to validate the engineering and technical feasibility of next generation EGS. And the long story short is that it worked. great, pretty much as well as anybody had expected, and then some. This flow rate of 63 liters per second is at the predicted temperature without drawdown. Is it's what's needed to de-risk a lot of the concerns that I touched on earlier. And then so after Project Red, they started on Cape Station, which is 2024 to present. And for this project, they have a partnership with Google, and they are targeting 400 megawatts of electricity, I think by 2028. And yeah, this is the case study that I shared with, or that Adam reached out to me about. And I'll just briefly pull it up on, oh wait, no, actually, I'm sorry, wrong slide. We'll get to that in a moment. So this is the results that they got for the first or phase zero of building. They've got high flow rate, high peak flow rate, high sustained flow rate, and no thermal drawdown, which are all that's what you need to see for these super low LCOEs to occur. And here's some of the industry hype around it. Mark McClure is a figure in the geothermal industry and described it as bonkers, incredible, off the charts, spectacular. And yeah, these are this project has really been giving people a lot of reasons to believe that the super low LCOEs and the scalability that this can actually happen. And it's it's the kind of thing that if the trajectory continues, it would change the world. So people are excited about that. So given their results to date, where they validated with Project Red, and then they further validated with Project Cape, we did an extrapolation to what does an nth of kind plant at 400 megawatts electricity generation actually look like. And this is where we found a 2.77 cents per kilowatt hour LCOE and 43.75% IRR with bicycle. And just to underline, yeah, this is highly optimistic, assuming best case scenarios. This is what the bicycle model that is more of a kind of a research comparative LCOE, not necessarily real world LCOE, but still very exciting nonetheless. And it's indicative of again that picture of could we really generate 20+% of our electric supply with geothermal, and the extrapolation is indicative that the answer to that could be yes. Hopefully is yes. So yeah, just quickly, some of the more fine-grained results from GeoFires here. We've got an average net production of 404. So that's bearing in mind that there's some parasitic loss to the pumps, so your actual nameplate capacity needs to be a little bit higher. And that's with 39 production and injection wells with 120 kilograms per second flow rate. Yeah, and then more the economic parameters, so 20-year project lifetime, estimated approximately 4.58 billion NPV. These other metrics that you can see if you care to read them. Yeah. And then obviously CapEx is, as I've touched on a couple times, a big portion of that. So we extrapolated to an approximately 1.5-ish billion in CapEx. So that's if you add the capital costs and the investment tax credit here, that comes around 1.5 billion. And yeah, it's a serious amount of money, but if you have it, it looks like the returns are there. If if this type of plant can be replicated and scaled out to sites beyond Fervo. Operating costs can be pretty significant. These are some of the components of them, and then this is not showing, like, for example, like property tax, insurance. There can be sales tax, income tax, you know, anything else you can imagine could also be subject to. A lot of people like one of the concerns is water costs as well. And yeah, that's another very positive metric that they've reported is a very low water loss rate, which is good because in some of these places you may not have unlimited amounts of water, even if you could, even if you had the money for it. So that's another engineering challenge. And then this is a comparison of the bicycle model to the SAM model, which is a prototype that I've been building, just showing that actually in this case the LCOE is a little bit lower with SAM. Your net present value is lower as well. The IRR can be different. And that's something that we'll be working on more is allowing comparison across different financial models, but just showing that there can be different interpretations of these numbers between different financial models, and SAM's is a bit different from bicycle. Okay, how am I doing on time here? I still got a little time. Okay, so yeah, touching on SHR. So SHR. This is an analysis that I did recently about as you increase your bottom hole temperature, your LCOEs can go down with SHR. And again, this is dependent on the outcome of technological advancements and assumptions about some of the engineering parameters. But from an enthalpy standpoint, there are reasons why SHR may be able to yield even lower LCOEs, and again, this comparative model with the bicycle model getting down to like 1.5 cents LCOE at 450 C. So yeah, it's another exciting area that is going on. One of the cool companies, super cool companies working on SHR now is Quaise Energy. And so as I mentioned earlier, drilling costs are the main cost driver right now, besides the engineering uncertainties. And Quaise is looking at whether we can drill holes into the earth by blasting them with a laser. And that's like it's not a joke. That's a real thing that they are actually seriously investing in, and they are, I believe, as we speak, they are testing this technology out. Well, they're testing the technology out. They are also separately preparing to do it at a site in Oregon called the Newberry Volcano. And yeah, if they're able to make this technology work, it would potentially drastically reduce the costs of drilling, and because it would be lasering instead of drilling, and that would make the economics for SHR or not even. You could drill a lower temperature. It would be huge. So that's super cool. And then yeah, here's some more maps and metrics around that. I think we're probably getting into Q&A territory here time wise. I might just save these for Q&A to have them on hand. Yeah, here's just some key companies, initiatives, and such to watch. There are BLM is doing geothermal lease sales, and actually there was just one yesterday that I'll show real quick. It actually set records for the maximum price paid per acre for geothermal leases, and yeah, this is the quick little analysis I did here. This is someone's LinkedIn post about it. And then actually here's another little analysis I did. So um, these are some of the parcels that were up for bidding that went for the highest amount, and these are wells nearby wells to these parcels that have been drilled with an estimate of the bicycle LCOEs. Um, so and that might give you just some idea of the relationship between bidding and what the potential LCOEs might be. So yeah, there's serious money is going into investing and developing these projects. You know, as we speak. So yeah, I think that's it in terms of the presentation part, and we'll open it up for Q&A and comments.
Yeah, so the first one came from Candace, and she said, what raw materials are needed, any critical minerals or things like that, compared to minerals needed in other clean technologies?
I am not an expert in that area, but my understanding is that far fewer critical minerals are needed today compared to solar. Certainly, it requires a lot of steel, and that I'm not an economist. I can't speculate on what the new tariff situation might how that might impact that. For SHR, I believe that it, there's the hotter that you go, the more potentially exotic materials you have. I can't really speak to which those are and whether they might be at risk, but um, in general, it's much more steel heavy rather than critical mineral.
Right. And then also, which category of geothermal is Fervo, being like next gen advanced closed loop?
Turbo would be EGS. Next generation entails EGS and closed loop, and Fervo is EGS.
And then what is Fervo doing well or better than other competitors in the geothermal space?
Um, I'm not an expert on that, but I think in general it's more that Fervo is the first to actually get funding and the right site and basically have a situation where they are de-risked enough to make the required capital investments that other people are hesitant to make. They have a partnership with Google. I believe they are getting like a kind of a special PPA price, which I heard informally might be around 12 cents per kilowatt hour. Don't quote me on that, but um, yeah, they are uh, uh, sort of the vanguard, and everybody's watching to see how things go with them.
Okay. And then Brian Yang asked, does the O&M, ooh, here we go, O&M costs make up or include makeup drilling costs?
In the Fervo example I shared, no, because Fervo is they have not observed any thermal drawdown. So for people that may not be familiar, the reason that you would need to re-drill is if you're experiencing thermal drawdown, which is where you have extracted enough heat from the volume of the reservoir that you're getting less to the point where your power production drops. Fervo, to my knowledge, has not experienced any drawdown and has repeatedly made assertions that imply that they don't expect to experience significant drawdown in the project lifetime. Whether that's actually, going to remain the case, there are experts that have theories about why that may not continue to be the case. There are experts that think that it could be, but that's what they're saying right now. If you if you do experience drawdown and you have to start redrilling, yes, that starts to negatively impact the economics potentially significantly.
Okay. And then related to that, Matt, if you want to come off mute and expand onto your thought there, you can, but I'll start reading off of there. Um, and then Matt said, I find a lot of these models take the ITC right off CapEx, where in the real world you need to lay out the cash and don't monetize the credits until after COD often, with hefty transaction costs in the mix. If you have a 4 to 5 year uh, dev timeline, that can move the needle on IRR.
That is absolutely correct. And that is uh, as I've been getting into more in-depth economic analysis, I come to the exact same conclusion. And in fact, one of the slides I showed was, if you recall, the SAM versus geofires, and there were two geofires ones or bicycle ones, and one was with the ITC corrected that way, where you are effectively, yeah, you're discounting, or rather, the bicycle model does not discount the future value of the ITC credit, right? Because the value of that money in the present is higher, or is higher in the future than it is now. Yes, 100% correct. And that's why work right now is in part focused on using Sam's financial model, which models that stuff more accurately.
Okay. And then Chloe asked, how critical is better geothermal discovery, which I think Zanskar is doing?
Yeah, that's another area I'm not an expert on, but it's in general the idea is that next generation geothermal de-risks and enables building projects pretty much anywhere, regardless of geology, or on much more common geological circumstances. Um, in the present, um, people are definitely looking for places that are geologically analogous to what Fervo is doing, right? Because they've proved that it works in this geology, which is a new geology for geothermal. But you're talking about trying to minimize the risk in your first and second of a kind projects. Well, it's safer to go with the geologies that match what's known to work.
Okay. And then I don't see any more questions right now, so I'm going to ask some stupid ones. So in my home state in Alabama, we had a huge scourge of oil wells just kind of like pocketing all over the place. And kind of to what you're saying, both in trying to get a bunch of the oil and gas workforce moved over to geothermal, or that could be a very like easy, low friction kind of effort. And then also potentially making some sort of effort to standardize the equipment or looking at actuality of the geothermal kind of like building process. Because to my understanding right now, geothermal kind of suffers the same kind of issue of some nuclear projects where like you still have like an individual project every single time, and it suffers like the backlog of engineering pulls for every single like step of that. And part of that is because it's so new, and there's not really off-the-shelf components that you can do like oil and gas has, or at least like the manufacturing kind of backload that oil and gas has. So, do you have any thoughts on that?
Yeah, I mean, there's certainly it's a nascent area, and with that comes, each first of a kind is gonna have some unique requirements that haven't been done before, and of course, the hope is that as more projects get built, it does get standardized, and yeah, like oil and gas is some of the key technical differences are that it's usually in sedimentary geology, whereas EGS is actually in hard rock like granite. Like hot dry rock is a term people use a lot, and the equipment that you need for that is just kind of is different. It's also higher temperatures, like oil and gas. I believe typically top working temperature will be around like 150 C. if we're talking about getting to 300C and beyond, you have to have different techniques, different materials, different approaches. So, but yeah, the hope is of course that the as adoption and deployment increase, the standardization comes with it, and yeah, but like drilling rigs, there you can reuse 90% of an oil drilling rig for a geothermal rig. You might have to use a different bit, you might have to get longer piping and drill strings. I'm not an expert on oil drilling, but just in general. But yeah, the skills for the operators are very similar, the equipment is similar. So yeah.
Well, I'm glad you said that because that was going to be my next dumb question is can we just repurpose the old wells that are just sitting there collecting dust or worse, outputting methane leaks or something awful like that and turn them into something else that's more productive and better for the environment?
Yeah, that has been an area of not insignificant research. Again, another area I'm not an expert in. And my understanding is that there are the scenarios where it makes sense are usually pretty limited, unfortunately. It does work in some cases. I believe the Pepperjack Mill Hotel and Casino in Reno, Nevada actually is has its geothermal cooling and heating that is um, built using repurposed oil wells. And I believe I took a tour of it, and I want to say they displace like $250,000 of natural gas use a year. So it can work sometimes.
It's awesome.
Yeah.
So then, if anybody else has any questions, please feel free to raise your hand or type them out into the chat. Otherwise, I'm just going to fill out time asking stupid questions. Sean asked, any thoughts on geothermal and geologic hydrogen?
Sean, I'm aware that's a thing. I couldn't really speak intelligently on it though. Someone said quiz demo day on April 23rd. That's cool. Materials we got. Yeah.
And then I think you had a slide for this. Did you have a slide for the total potential capacity for geothermal, like in the US or something like that? Or was it just for California?
Yeah, the that slide was the Ricks and Jenkins study that was predicting 250 gigawatts to 750 gigawatts by 2050.
Okay.
Oh yeah, I think somebody asked why not more? And I think the hope is that it could indeed be more. A lot of it just high level, it's dependent on where the economics of how deep you can drill while still being profitable pan out. And that's just something that I think remains to be seen. But yeah, it depends. It depends the depth that you posit will be economically leverageable.
Is it,
Okay.
well, just a follow up, Jonathan, is it more of a economics question or more of a tech question for both, right? Given like what Fervo's done already, is the tech basically there to get us to 20%? It's more economics, or do we still need to really do a lot there?
It depends who you ask. I would say it's a little bit of both, but the on the tech side of things, the data that's been coming in consistently has not just been meeting expectations but exceeding. So yeah, it's like I said. I mean, it's highly complex. There's a lot of factors to it. There's the subsurface. There's the well engineering. There's a whole host of different factors, but yeah, that's the hope.
Cool. Anyone else want to jump into the last question? Adam, do you want to
Yeah, last question for me. Do you see anything policy-wise that could help move things along or just reduce friction for the industry in general?
Yeah, there's again, we're getting into I'm not an approved expert on this stuff territory, but there's permitting streamlining that there's lobbying for right now, and I do believe some of that is going through. Obviously investment and production tax credits are great, and I'm sure everyone here hopes that those remain in place. There's research initiatives like ARPA-E, which we also hope remains in place. Um, and yeah, I mean, one risk with the oil and gas transferability, it's a positive in some aspects, but it's also a risk because if oil and gas become significantly more profitable, all of a sudden it's a boom and bust industry, then that takes away from your availability to drill geothermal wells. So, there's I won't speculate too much on which policy levers could or should be pulled to favor geothermal, but I'm sure you can think about those.
Cool. And Jonathan, if you have an extra minute, if you don't have to jump, Chloe asks what startups are worth watching in geothermal beyond Fervo and Case. Oh, it sounds like we need a slide for that. All right, can you share the slides?
Yeah,
Share them out here as well.
and
Have to jump.
I have plenty of time. No, I have plenty of time now. I'm more than happy to answer questions until you guys get tired of me.
Okay, I'm gonna jump. Adam, I'll make you the host, and then anyone who has to jump as well, feel free. But thank you so much, Jonathan.
You're very welcome, and thank you for inviting me. Where do I have? Yeah, so Fervo, Quays, Mazan.